Predicting Position Graphs, a 9th grade conceptual physics video. This is a picture called flip-flop kick. A flip-flop is kicked off of a foot. It moves to the right. This event was filmed by a high-speed camera at 300 frames per second. Then this composite image was made every 20 frames so that each image is 0.0667 seconds apart. We would like to know what is happening to the motion of the shoe in the vertical direction and what is happening to the motion of the shoe in the horizontal direction. Try to write descriptions using words like up, down, left, right, getting faster, getting slower, etc. Now try to draw position versus time graphs for both directions, horizontal and vertical. In the vertical direction, if you imagine lines across the screen, you can look at the vertical displacement of the flip-flop. I'll draw the lines across the screen for the shoe on the way up. Each line is in the middle of an image. Do you think these lines are getting closer together or farther apart? If they're getting closer together, what does that mean about the velocity of the flip-flop on its way up? Now I'll draw lines for the flip-flop on its way down. Are these lines getting closer together or farther apart? If they're getting farther apart, what does that mean about the velocity of the flip-flop on its way down? In the vertical direction, the flip-flop is going up, getting slower. Then it peaks and has an instantaneous vertical velocity of 0. Then it comes down, getting faster. The graph of vertical position versus time would look very much like the actual motion in the picture. Now let's look at the motion in the horizontal direction. If you imagine lines across the screen, you can also look at the horizontal displacement of the flip-flop. I will draw the lines across the screen for the shoe as it goes. I'm tracking the horizontal position of the middle of the flip-flop. Are these lines getting closer together or farther apart? If they are about evenly spaced, what does that mean about the velocity of the flip-flop as it goes sideways to the right? In the horizontal direction, the flip-flop is traveling at a constant velocity. It is not getting faster or slower. The graph of horizontal position versus time would be a line with a constant slope, meaning that the horizontal displacement is constant. It keeps moving the same amount each second. This picture is called backspin bounce. A bouncy ball is thrown starting from the right-hand side of the screen, moving to the left. It hits a wall at about the same height as it was thrown, and then it bounces downward to the floor while moving to the right. Then it bounces upward and makes an arc. What's happening to the motion of the ball in the vertical direction? What's happening to the motion of the ball in the horizontal direction? Write down your descriptions using words, including up, down, left, right, getting faster, getting slower, constant speed. Now draw position versus time graphs in both directions, horizontal and vertical. These are more complicated than the flip-flop. In the vertical direction, the ball is going up, getting slower, and then it starts to go down, getting faster until it hits the wall. It continues to go down, getting faster until it hits the floor. Then it goes up, getting slower, until it reaches the peak of the arc. Lastly, the ball goes down, getting faster. Here's what the graph would look like in the vertical direction. Note that the shape is basically the same, but the ball keeps going forward in time. In the horizontal direction, the ball is going to the left at a constant velocity until it hits the wall. Then it immediately reflects and goes to the right at a slightly slower constant velocity. We can tell it's slower because the images are closer together in the horizontal direction. Then it hits the ground and continues moving to the right at an even slower constant velocity. Here's what the graph would look like in the horizontal direction. Note all pieces are straight lines because the speed is not changing. Upward diagonals mean it's going to the right, and downward diagonals mean it's going to the left.